We will see gradient descent from deep learning neural network. It's an optimization algorithm commonly used to train machine learning models and neural networks. It trains machine learning models by minimizing errors between predicted and actual results. So it's a training on data that these models can learn over time. So this is the example. So what happens? This is a mountain or hill where a human is being in the top, like blindfolded in the top of the mountain. So what happens to get down? We are having small steps. Since if it is big steps, that not might be the real way to get down and feel the slope, whether the surface is flat or not. So and we are repeating it until it is flat. So to find the lowest point. So this is the example to illustrate the gradient descent. So in real time in Netflix, what happens for a movie KGF, the actual rating is 4 by 5, which is given by the user. The predicted rating is 3 by 5 from Netflix algorithm. So that's minimize the error between actual and predicted one. So this is the actual and this is the predicted. So what happens between those is the to reduce the error we are doing on this one. So what happens? We can able to see from here the types of gradient descent. The batch gradient descent checks all training data before adjusting. It's slow but precise. Stochastic gradient descent. This is adjust after each data point, fast but shaky. This is mini batch gradient descent. Uses small group of data, most common in practice. So we see the difference between batch, stochastic, and mini batch. So from here we can able to see the use case. It's applicable for small data set, the batch one. For stochastic, it's for online learning model. Mini batch is used for most real world problems. Updates per epoch. So we will see the epoch later. So it is one on this one 10,000 fast, and this is 100 balanced. Noise level is low. This is high and this is moderate. Hardware, this is poor and this is also poor, but this is the best one. We will see the key terms, what's happening in this gradient descent. The cost function or the loss function measures how wrong the model is. The difference of predicted and the actual, mean squared error, we will get this one. So the learning rate, the step size for parameter updates, gradient, direction and steepness of cost function slope. Epoch, this is the important one full pass through training data. Batch size, number of samples used per gradient update. Convergence, when the cost function stops improving significantly. Local versus global minimum. The global minimum is the best possible model. Local minimum is good enough. Optimizers, so these were important: SGD, ADAM, RMS prop. So in the real time, we use in bank fraud transactions by training the model. The autonomous vehicle, which is used in Tesla, medical diagnosis by seeing the patient records, and in supply chain like Amazon, Walmart, etc. So this is the overview of a gradient descent from deep learning neural network. Thank you.